At this time, I'd like to introduce our first presenter. Steve Lederer is Senior Product Marketing Manager for System Sensor. Steve, take it away.
Thank you, David. As David just mentioned, I'm Steve Lederer. I am the Product Manager for FAAST and PipeIQ, the software that supports the FAAST aspirating smoke detector. So first, today in this webinar, we're going to give a general overview of FAAST fire alarm aspiration sensing technology and a quick overview of PipeIQ before we get into actual project creation, configuration, and the monitoring function in PipeIQ. And then Nick, our application design specialist, will go over the Pipe Wizard, manual pipe design using PipeIQ, and also the calculations and reports that are provided in the PipeIQ software. So first, a little bit about FAAST. FAAST is a highly sensitive air aspirating smoke detector which uses a fan and a network of pipes to draw air in from a protected space into the highly sensitive smoke detection chamber. Now, FAAST is capable of very early warning and early warning protection per NFPA 76, as well as standard fire detection coverage per NFPA 72. In standard fire detection applications, FAAST can cover up to 8,000 square feet. A couple of other features that we've built into our FAAST aspirating smoke detector is some enhanced nuisance rejection capabilities. First is the particle separator. Now, the particle separator really enables FAAST to be deployed in applications that you would not necessarily deem traditional for aspirating smoke detectors, such as very dirty and dusty environments. This particle separator actually forces the airflow to make a dramatic turn, and only small particulates like those associated with particles of combustion are really going to be able to make that change in airflow direction. This automatically voids the air sample of any large particulate through the exhaust before the sample in the chamber can actually be contaminated. The next part of our nuisance rejection capability is our chamber itself. The chamber of FAAST uses unique dual vision sensing technology, which uses a blue LED which can detect minute particles of smoke, so particles that are extremely small and would really only be associated with particles of combustion. The second portion of the dual vision technology is an infrared laser. This infrared laser looks for larger particulate which wouldn't be associated with particles of combustion. And then our onboard algorithms analyze the signal from both of those light sources and make the decision whether it's a smoke condition or if it's a nuisance condition and can be avoided. FAAST also has an onboard Ethernet port enabling local area and wide area monitoring of a FAAST device either via the web or via the PipeIQ software itself. The IP connectivity can also facilitate up to 6 email addresses for notification when an alarm or a fault condition occurs. Finally, the Ethernet port also communicates TCP Modbus for integration into building management systems. Finally, FAAST is also available as an intelligent addressable device for several panel manufacturers such as Notifier, Gamewell FCI, and Fike. This means FAAST is sitting directly on the signaling line circuit like an ordinary spot detector, eliminating the need for any extra hardware or software that would be needed to interface another aspirating device with the fire alarm control panel. So a quick overview of PipeIQ. PipeIQ is the software needed to design a pipe network for the FAAST system, which will be the main focus of this webinar, and we'll get to that in a little bit here. Using PipeIQ, you'll be able to ensure that your pipe network meets application-specific requirements, as well as adhere to the NFPA performance criteria that you're shooting for. After the pipe network is designed, PipeIQ will generate a BOM and a pipe layout report to help you facilitate ordering and the actual installation of the FAAST system and the pipe network. PipeIQ is also used to configure a FAAST device for its obscuration, and intelligent devices will also set their address using PipeIQ. In addition, there are several other options to program, which we'll go through in just a minute, such as configuring events to latch or track, as well as configure the device for its IP connectivity and email. Finally, PipeIQ can be used to monitor a FAAST device. So when connected to the device in PipeIQ, you can get a live view of the front of the panel. So what the panel is seeing, what it would look like on the user interface, is exactly what you'll see in PipeIQ, as well as see a trend graph of information such as the perceived obscuration in the chamber relative to your preset alarm levels. So now we'll move over to PipeIQ itself. So first things first, you need to download and install PipeIQ, which you can do free of charge from systemsensor.com/FAAST. There's a brief form you need to fill out on the web page, essentially just giving us your email address so that we can contact you when there's a new version of PipeIQ available to download. Once PipeIQ is installed, you'll open it up using the PipeIQ icon on your desktop or under the Windows button under Programs. And then you'll enter into this screen here, which is just the default screen of PipeIQ. The first thing you'll need to do to start is you'll need to create a new project, either using the New button or selecting File and then New. Give your project a name. And then the first option that we'll get in a second here when it's finished loading, we'll be asked whether we want the U.S. customary system or the metric system. So whichever one you're more comfortable with, we'll go ahead and use the U.S. customary system for this webinar. Hit OK. And then you've got a general disclaimer. Just read and acknowledge the disclaimer. And we've got ourselves a PipeIQ project. So PipeIQ is set up like any other Windows program. You've got your normal file menus up at the top. You can change the language of PipeIQ to up to 13 languages. So you would select the language, exit out of the program, and reboot, and it will be in the language that you require. On the left, we've got our tree pane view. So we've got our project level settings, our building settings, our floor settings, and the FAAST device itself. And at the bottom, we've also got the three different views, the three different sections of PipeIQ that we can interact with: the configuration, design, and monitoring section. You can also access those different sections under the View tab at the top. So in order to start configuring a FAAST device, we need to double-click on the device in the tree view, and it will bring us to the general configuration pane in the configuration section. The first option we have here is the model number. So this will suppress PipeIQ to only display information that is relevant for each model. So some intelligent models have some functionality that's actually controlled by the fire alarm control panel. So selecting those models will restrict entry of those criteria from PipeIQ, and that will only be allowed from the fire alarm control panel. Below that, we've got some general information such as facility name, location, device location, and contact person. Over here to the right, we can configure the buttons on the front of the FAAST device. So on the front of the FAAST unit, you have three buttons for test, reset, and isolate. These can either be configured to be locked out so that if somebody walks to the front of the device, they can't interact with the buttons, or they can be unlocked, which would be done by unchecking these boxes. There is a method for unlocking the buttons at the front of the device using a sequence of button presses to enter a 4-digit numeral-only passcode. So that passcode would be configured right here in the button activation passcode section. Finally, device date and time. Now, this date and time should be set right before you send a configuration to the FAAST device. Once you set this date and time, say you set it at the beginning of the project and you go to do some pipe design, this clock is static. It won't move as you're using the program. So this should be set last, the final thing you set before you send the configuration over to the FAAST device. The next tab in the configuration section is the relays and thresholds. The first option that we have at the top left is to select whether the alarms and faults are latching or tracking. So if the boxes are checked, that means that the alarms are latching, meaning that if a smoke condition is enough to generate an alert, and then the smoke condition clears, that alert would persist on the panel, even if the chamber is now clear. If we uncheck it and configure it for tracking, that means that if that smoke condition goes up to the alert level, the device will enunciate the alert level. But if the smoke clears the chamber and the alert condition goes away, we'll no longer be showing the alert condition on the front of the device. The next option over here is acclimate mode. So you can see when acclimate mode is disabled, we have our standard day, night, and weekend threshold levels available. If we enable acclimate mode, those gray out, and we have the min and max obscuration levels available. So what acclimate mode does is it allows you to enter an obscuration range that the device will make itself as sensitive as it can in that range based on the ambient particulate level. So basically you give it a low and a high, and the device will adjust itself inside that range based on the particulate level in the environment trying to be as sensitive as it can inside that environment. If we disable, we have our day, night, and weekend mode available. This is just setting static alarm thresholds for day, night, and weekend. So if it's say a manufacturing facility and there's a process running during the day that won't be running at night, maybe I want my device to be a little bit less sensitive while that process is running. So I can make the device less sensitive during the daytime as opposed to nighttime. And up here using the clock at the top right, we can set when our nighttime actually starts and ends. Finally, each alarm level can be delayed for a period of up to 60 seconds. So if you want the condition to persist for any amount of time before that alarm level is actually enunciated, we can program each of these delays for up to 60 seconds. And then you'll notice there's a rules button here at the bottom right. Essentially, this is just giving you the rules by which you have to set your threshold levels. So it's basically saying alert has to be your most sensitive, followed by action 1, action 2, fire 1, fire 2. Essentially, it's saying that fire 2 cannot be set more sensitive than action 1. They have to be in a progression. The final tab in the configuration section is the network configuration tab. So using this identification number at the top left, this is where we would actually set the device address for intelligent devices. So this is, using these numerals is where you set your SLC loop address. Over here to the right, we've got our IP address, subnet mask address, and default gateway information. FAAST can either be assigned a static IP address, or the IP address can be obtained automatically using DHCP. Now this information would generally come from the IT group of whoever you're working with. So if the device is configured to sit on a local area network, the device is actually able to be viewed remotely using a web server. So similar to what I'll show in just a second in PipeIQ on the monitoring tab, that same information can be seen using the web server. In order to log in on the web server, we do need a password. So over here in the web access password section, that's where we would give the device its password so that we can log in using a web browser. Below that is the administrator password. So the administrator password is used to connect to the device using administrator mode. Administrator mode is necessary to actually send a configuration or retrieve a configuration from the FAAST device. So there are two modes you can connect in: read-only mode, which basically only allows you to view the monitoring section and how the device is configured. No changes will be able to be made in read-only mode. And then administrator mode, which gives you the full functionality to actually configure or retrieve a configuration from a device. Below that, we've got our mail server configuration. So again, FAAST is able to send out emails based on certain event criteria. The device does need an email address, which would be put into the sender account information. And it also needs the SMTP server name. Again, this would generally come from the IT group with whoever you're working with. And finally, we would configure our actual email address. So these emails are completely customizable. You'll see when you enter in an email address, it allows you to interact with the checkboxes. So if it was say a maintenance person or a facilities person and they only need to be notified when there's a fault condition, you could configure that email address to only receive fault condition emails. Or say it's a building owner and they need to know when there's a fire condition, you can select them only to receive the fire conditions. So that's a general overview of the three tabs inside the configuration section of PipeIQ. Now we'll move on to the monitoring section. So I'm not connected to a device right now in order to facilitate being on this webinar, but this is a live view of what the actual front of a FAAST device looks like. So in normal operating mode, you would have a green indication here and two green LEDs centered in the bottom to show normal airflow. As the conditions on the device change, if you're monitoring the device in PipeIQ, say there was a filter fault, you would get a yellow light here under the fault condition and a yellow light here over the filter condition to enunciate whatever the fault is. And again, this is real time. This is a straight-on view of what the device is actually seeing at a given moment. Next, we have the option for a trend graph. So this is actually going to trend out the obscuration perceived in the chamber at a given time. So, you know, if you've got a rising particulate level, and it would also give you a fixed line for your set alarm condition. The next view we have is a log view. So FAAST can store up to 18,000 events in its history. These are events such as a reconfiguration, power on reset, and then fault and alert and alarm conditions. So this would be just a log view of all the conditions that have ever happened on the device. So that's a brief overview of the configuration and monitoring sections of PipeIQ. And at this point, I'm going to hand it back over to David for the first poll question.
All right, Steve, thank you very much. And we do have a couple of questions posted. So if you do have questions so far, go ahead and use that questions tab on your GoToWebinar control panel and type them in. We do have Luis Barros, one of our FAAST experts, offline and answering those. So you see some of those coming up within probably your chat or questions box, and we will take a couple live. So the first poll question, so come back to your screens and answer this for us if you would. What's your most difficult part about designing an aspiration smoke detection job? So is it using the pipe layout software like this or maybe others in the marketplace? Knowing where to set device obscuration levels? Knowing how to design for a specific application? Knowing what detection classifications to use? Or is it something other maybe we haven't posted there? And if you do select other, we just want to encourage you, go ahead and use the questions option and type in what your other is. We'd love to see what those responses are, and we can cover those as time permits here. So go ahead and vote. Guys, we've got a couple of questions posted here that I just wanted to answer live. Let's see, the first one. Steve, you were talking about the addresses, and they're wondering about, does the address come from the detectors or the modules?
So the intelligent FAAST system does not require any modules, so you're actually setting the detector address on the SLC loop.
Okay. All right, very good. Hope that answers your question, Adam. So if you have other questions, go ahead and post them. The second question is, can you have both the IP and SLC connectivity at the same time?
Yes, absolutely. So the IP is obviously coming from just a standard Ethernet cord connected into the network, and the SLC loop can communicate while that IP network is up and running.
Okay, wonderful. Third question I can answer here, they're asking about the archived webinar. They want someone else in the office to see this, and they're asking if it includes the audio as well as the slides. It will. It'll be like a small Windows Media Player movie, and we'll have that posted early next week. So thanks for asking that question. Let me go ahead and close the poll question. 70% of you have answered this. We have over 400 people online with us today. And I don't know if I mentioned this, but I'm going to go ahead and share these results with you. So Steve and Nick, they're saying that the most difficult part of designing an aspiration job, by and large, is knowing how to design for a specific application, 41%. So those probably vary from transportation or data center or telecom or whatever that might be, all the places aspiration's used. Second highest was knowing where to set device obscuration levels. So it's good we're covering that.
If I could just jump in there real quick
Sure.
to address that, David. We'll go over this, and we'll provide a link a little bit later in the webinar, but we do offer design services. So if you have any questions about how to design for a specific application, you'll go to systemsensor.com/FAAST, and there's a design resource link. So we do offer that service.
Okay. Others that put other here, I should say, attendees that put other, they're saying things like selecting the proper fittings and the hardware. Let's see here. PipeIQ, let's see. I'm just trying to see what other things are posted here. So it looks like how to address the FAAST system is something else. So those are other comments that are made. So if there's questions there, actually, we'll circle back to that. Let me take the poll question down. And now we're going to move to Nick Gomez. Nick is our application design specialist. He would be your point of contact if you'd like help with a design project. So Nick, you're up. Take it away.
All right. Thank you, Steve and David. Welcome all to PipeIQ 101. For those who are familiar with AutoCAD and Revit, we try to implement the same concept in our design software. We have two ways to help you design a system, by using Pipe Wizard or creating a custom design. Now to get started, the first thing you will need to do is click on the FAAST device and make sure you're under the Pipe Design tab. You're going to see a blank screen. Okay, so by using Pipe Wizard is a helpful tool that allows you to design a system by inputting the required information of the application. But keep in mind, it should only be used to design basic cookie-cutter applications such as basic squares or rectangle applications. Think of it as the starting point. Okay, so the first thing you want to do is click somewhere on the screen itself, bring up Pipe Wizard. It's going to pop up a window. Pipe Wizard will ask you a series of questions to help you design the system. The first question is going to ask you, what are your sensitivity requirements? So it's going to ask you for the constraints itself. It's either UL, ULC, or EM54. EM54 is actually a standard that's used by our European counterparts. The classifications, as also indicated per NFPA 76, which is early warning, and standard fire detection. So for the purpose of this webinar, we're going to stick to standard fire detection. You do have the ability to actually change the obscuration level on standard fire detection as long as it's not less than the requirements per NFPA. So let's say we're going to change it to 900 square feet. The transfer time is 120 seconds. Hit next. Now it's going to ask you where will the pipe network be located. So the first thing it's going to ask you is dimensions of the room. So it's going to ask you for the length, width, and height. So let's say our length itself is 75 feet. Our width is 70 feet, and our height, we'll just keep it at 14. Under pipe type, it's actually telling you that in order to cover this area, it's going to require 3 rows to maximize the coverage of per NFPA 76. To the right of it, you're going to get an isometric view, just to kind of summarize exactly what you inputted on the boxes for the dimensions. Hit next. Now it's going to ask you where will the pipe be located at. So if you scroll down on pipe location, it's going to give you 3 different options. You have below ceiling, above ceiling, and below floor. The difference between the 3 is below ceiling is an exposed pipe that will be located anywhere between 1 inch to 12 inches. Above ceiling means that the pipe is actually in above ceiling void itself, and you're going to require capillaries in order to sample the space itself. Below floor is if you're doing underfloor detection. So we're going to stay to above ceiling. The distance from the ceiling itself, like I mentioned, it needs to be anywhere between 1 inch to 12 inches. We're just going to keep it at 4 inches. The pipe network direction, actually, this is where the pipe, how the pipe actually is going to be laid out into the room itself. This would actually make more sense once I show you guys how to import a DXF file. And we'll get to that later. So for the time being, we'll just keep it to left to right. Hit next. Now it's asking you what type of pipe will be used. Standard pipe for air sampling system is your typical CPVC pipe. You do have the option of selecting other pipes. The one thing we do advise you is that if you are going to change the pipes itself, you do confirm with your local ASJ to see if it's going to be acceptable by them. As far as the pipe diameter, you have the option between using 3/4 inch or 1/2 inch, schedule 40 or 80. Your sample hole sizes, you have different sample hole sizes. Standard will be 1/8. Obviously, the hole sizes will change and vary depending on the design itself. But in order to create this file, we're just going to keep it at 1/8. Hit next. Where will the detector be located at? Whether the detector be located inside the room, and if you actually choose outside the room, you're going to get prompted by a warning letting you know that the exhaust must be located back into the room. It's being monitored in order to avoid pressure differentials. So we're going to go back inside the room itself. Now this is from the floor. I typically advise people to put it about 5 feet above the floor, which is your average eye level. Hit next. Now you will see a summary of everything we kind of went through. Just verify that everything complies with your requirements. And once it's done, you hit finish. Go to Zoom Extends here. You extend the pipe. Now there are several views that will allow you to see the design you created. Keep in mind these views are very important because they will help you modify the system when creating a custom design. So you have your top view, your front view, your side view, and your isometric view. With any of these views, with the exception of isometric view, you have the ability to modify the design. So if you needed to add a vertical pipe, I would recommend going either the front view or the side view in order to add a vertical pipe. If you needed to add a horizontal pipe, you would do that from the top view itself. Okay, so now that we verify our design itself, and we know that the system has been created, we will need to check the design with the calculations. So we go to the calculator. The calculations will show you a summary of the overall system. Will also indicate if the design is optimized. So the calculator itself would actually show you the pressure of the detector itself, your different levels from alert all the way to fire 2. Your threshold, which actually governs your hole sensitivity, which is also known as your aspiration levels. Your day-night level, day, night, and weekend levels. Then your constraints itself, which is your flow balance. We know that it's UL standard, and the classification is under standard fire detection. So you have your different hole diameters where you have the ability to change them if you require. Okay, so you have your absolute distance, which is the distance from the detector to the sample hole. Your relative distance is the distance between the sample ports itself. Your transport times. Your hole sensitivity, again, this is also your obscuration levels. Your pressures, your flows liter per minute, your flow percentage. Your pipe diameter size is 3/4 inch, which actually, it's, if you break it down, it's 0.824 in diameter, inner diameter. Your capillary, we actually chose capillaries. These boxes will be highlighted. Your capillary length, for the fact that we don't have a capillary, it's indicated as 0, but if you did, you'll have a number in these areas. Same thing with your capillary diameter. Now we go to OK. The system looks fine and everything's optimized. Now we want to go and view these reports. So there's 3 different reports. You have a pipe layout report, you have your bill of material report, and then you have your consolidated bill of material. The difference between the 3 is your pipe layout report is basically going to give you all the characteristics for your system itself. So it's going to give you your transport times, your obscuration level, your flows, sensitivities. Your bill of material is exactly what it is. It's going to give you a report that indicates all your pipe lengths and all accessories needed for your design itself. Your consolidated bill of material is the same thing as bill of material. The only difference will be if you have multiple devices under one file, it'll consolidate everything into one report, giving you your overall estimate. So let's go and click on pipe layout. You're going to get a pop-up with general information, obviously the project name, location, layout name. If you choose to put your name as the designer itself, you have the ability to do so. The dates, and then the format which you want it, whether it's in decimeters or feet or inches. Let's generate it. Okay. So now that the system generated the layout report, you will see that the top portion of it is just, again, your general information. The summary is your system constraints. So you have your minimum and your maximum hole sensitivities and transport times. Your design constraints, again, we know that it's UL, standard fire detection. It needs to be under 3.2 percentage obscuration per foot. It needs to be under 120 seconds. Okay. The environment itself. Environment is actually crucial to input the environment itself. If you're doing applications in, let's say, in Colorado, where the airflow might affect the transport times of the detector. Your drill schedule, your holes, your transport times. Okay, now your sampling hole performances is actually telling you, again, your transport times, your pressures, your flow rates, everything seems fine. Your detector thresholds, this was actually, again, as I mentioned, this is actually what's going to govern your aspiration levels. So we didn't have to do anything, so it all remained the same. Everything should be fine. your aspiration levels or your sampling hole effective sensitivity. So you have day, night, and weekend. Obviously, under Fire 1, we're under 3.2%, which is the requirements per UL and NFPA. And if you look at Fire 2, you actually see a triangle with a black box on it. And the reason you're getting that error or warning is for the fact that we exceeded the 3.2 aspiration level per foot. In order to change this, again, all you would need to do is change the threshold under the calculations button in order to bring it down to 3.2. Okay, so now night, weekend. Here's the weekend report. So now you're going to get a couple isometrics. So the first isometric you're going to see is your pipe layout isometric, which indicates your pipe locations. So for example, you will refer to P1 and refer back to the report in order to know what the length of that pipe is. Your schematic holes isometric, which actually tells you where the hole is located in relation to the calculations. Your sampling hole locations, which is the distance of the sampling hole from the detector itself. And finally, your sampling hole diameter, which is your orifice size of the sampling hole itself. Obviously, we know that everything was 1/8 and the system was optimized. Now let's take a quick view of the available toolbars to assist you in the pipe design. So we talked about Pipe Wizard. Next is undo, redo. Now with undo and redo, you actually have the ability to recall or redo the last 10 commands. You have your cut, copy, paste, delete. So if you want to disconnect the pipe itself, all you would do is select the pipe, just drag it out, select it, and delete it. Okay, now we want to put it back to where it was, so we want to redo it, and it connects it again. Delete all deletes the entire system, so we go ahead and hit delete all. You will get a warning saying, are you sure you want to delete the entire drawing? You would say either yes or no, depending if you hit it by accident. You have your pan, which allows you to pan the system. Your stop pan. And then you have your zoom in and zoom out. You also have the ability to zoom in and zoom out using your mouse scroll. You have your zoom extents, your calculator, which we went through. Then you have your settings. Again, the settings, it's a lot of the stuff is kind of repetitive, but it's just to make sure that you know the design you're actually creating. So the constraints again, your classifications, and then you have the parameters for the FAAST unit itself. The environment, and this is what I was mentioning earlier. For normal, you want to input the normal ambient temperature. This is crucial, especially if you're doing cold storage applications or high humidity areas. You want to input that data in order to calculate the system and know if you're going to have any flow issues or any pressure issues. Again, astrometric pressure. If you know the altitude too above the sea level, you would insert it here, or if you know the pressure itself, you would modify that there. Under pipe design, now there's 3 different colors under pipe design. So you have your selected, your connected, and your disconnect. You also have the ability to change any of these colors if you choose to do so by clicking on the color chart itself. Hit OK. Now let's say that the layout changed and you needed to extend the pipe. But in order to do so, you need to offset around the structural beam. So the first thing we want to do is double click on the pipe itself. You're going to get a pop-up and you're going to get the characteristics of that pipe. So for the fact that the pipe was already created, we already know that the length was 48 feet, the starting hole, and then the distance between sample ports itself. And then we know that the diameter was 3/4 inch piping, our hole diameter. Obviously we could change any of this as well. And then start from, the reason this is crucial, and this is something you guys should remember, is for the fact that this actually goes in the direction of the pipe you want it to flow. So for the fact that we know that the detector's on the left, we want to go from left to right, and that's what's highlighted here. And then add an end cap. If this is the last pipe, obviously you need an end cap in order to plug the system itself. So since we're modifying the system, we want to remove the end cap. We have the ability to add a hole. So all you have to do is know exactly where you want to add that extra hole. Insert hole, and I would actually populate that hole for you. You do have the ability to modify the sample ports as well. And then you have delete hole. So what you want to do, obviously, just to show you guys how the system calculates, we want to delete all these sample ports. Okay. So now the constraints are still there. We want to calculate the sample holes to bring it back to what it originally was. If we weren't putting sample ports on this pipe, we would actually select pipe without holes. But for the fact that we want to keep the sample ports, we want to just choose calculate and place holes. And if you want to add capillaries, you have the ability to do so as well. You can modify the length of the capillary as well. You could maximize it up to a total of 26 feet per capillary if you choose to. We'll keep it at 3 feet. Hit OK. Now we want to change our view, obviously, for the fact that we're doing a drop to get around that structural beam. We want to zoom in, select the pipe we're trying to connect to, and then here are your pipes itself. So you have your add vertical pipe, your horizontal pipe, your diagonal pipe. Now, for a very important note to remember is that the pipe selected reflects the view you are in, as I mentioned. So if you wanted to add a vertical pipe from the floor to the ceiling, you will need to change from top view to either front or side view in order to add the vertical pipe. As mentioned, it's all in relation to the view you are in. So for the fact that we're already on side view, we have the pipe selected itself. We want to add a vertical pipe. And let's say the beam itself is 2 feet. And that's how we're changing. We're not adding sample port. We're not calculating holes. The starting point, we obviously we want to go from the top to the bottom, so we want to change that. And then we want to select pipe without holes. So there's your pipe. As you see, it's red, meaning that the pipe is actually disconnected. So what you would do is select the pipe itself, and you have two options to do this. You could grab the pipe and just drag it, and it connects. Or you can select the pipe, hold down Control, select the other pipe, and hit the auto connect, and it will connect it for you. So let's go ahead and add the horizontal pipe now. We want to get across 2 feet. Again, no sample ports. We're just going to drag it to it and add the other pipe. Again, 2 feet. Now we want to change, obviously we want to be conscious of the orientation of the pipe. So now we're going from bottom to top, which is fine. Pipe without hose. Oh, there it is. And now we want to extend that pipe. So we want to add a horizontal pipe. Let's say it's 2 feet. Your starting hole should be the total length should be 20 feet. Your starting sample port should be 2 feet, and your distance between sample ports should be 10 feet. Now we want to calculate and place holes. We want to add capillaries, and then add an end cap, because that's the last pipe. Hit OK. We created the pipe itself. We want to connect to it. We want to select using auto connect, and then connect it. Okay. So as you see, that's how you will modify the system itself. So obviously we need to do it for the rest of this system. So we want to go back to top view, actually change it to side view. Double click on the pipe, again, remove the end cap, hit OK. But now this time, instead of going through each pipe itself, we just want to do a copy and paste. So we will select the pipe we're trying to copy, hit copy, select the pipe we're trying to connect it to, hit paste, and just drag it to it. Again, copy, select the pipe we're connecting to, paste, drag to it, and one more time, copy, I'm sorry. We want to select this pipe, copy, select the pipe we're trying to connect it to, hit paste, and the last pipe with the sample ports is copy, select the pipe you're trying to connect it to, and paste. Okay, so now the last piece of pipe is the only thing we need left for this design. Again, just not sorry, this is repetitive, but we'll just make this quickly. Remove the end cap itself. Go to side view. Copy, paste. Hit the auto connect. Copy, paste. Copy, paste. And the last one is a copy and paste. Okay. So obviously we offset it around the beam itself. The only thing we forgot to do is add the capillaries on the pipes right before the beam. So let's go back and make sure we add those. Okay. And now your system has been modified in order to go around the structural beam and actually give you the ability to extend the pipe network as well. Okay, so if you do isometric, you're able to see how the capillaries and how the beam goes around the pipe. Now we do a calculations just to verify that the system is optimized. We would actually see that the hole sensitivity is coming up with red flags. Obviously, we know it's wrong because it's above the 3.2 aspiration level required per UL and FPA. So in order to modify this, as mentioned, all you will need to do is change the threshold. So let's modify this to 0.15. And it automatically fixed it for you. So as you notice, everything else was 1.8 at one point, and it modified the system in order to completely optimize it and give you the transport times and fix the pressures. It changed your hole diameters to different sizes. Okay. So now that we know the system is fine, we just said OK, save changes. Okay. So lastly is probably the funnest part of PipeIQ. We're going to hit delete all. So now we want to import a DXF file. So just make sure that the DXF file is a DXF file, not necessarily an AutoCAD file. So what you want to do is import the file itself. We want to choose DXF file. Now it's going to give you a pop-up saying that the file you imported is not to scale. We're going to need to scale it. Scale the project. Say OK. Do a zoom extends. Okay. So for the fact that we know that the system is not scaled, we do need to scale it. In order to do so, it will be using the measuring tape itself. So we just got to pick a point that we know the value for it. Typically, I like using doors for the fact that it's typically 3 feet. So you want to select the measuring tape itself and measure the door. You're going to get a pop-up. Now it's actually telling us that the door width is 21 feet. Obviously, we know that's wrong. What we want to do is hit Edit, change that to 3 feet, hit OK, and now the system should be to scale. So if we take a measurement again, it actually tells us that now the door is 3 feet. So we know that the system's to scale. Okay. So let's say we wanted to do a layout for just the cubicle area itself. So the first thing we would do in order to get started, we will measure the area. And it's about 52, 53 feet. And then we measure the other side. And that's about 37 feet. So now that we know the measurements itself, it's 52 by 37, we want to pick where the detector should be located at. So we want to select anywhere on the screen. Typically you want to be right on the center. So we would choose this location, go to Pipe Wizard again. We want to do variable warning, We want to input the measurements. So the length was 37 feet, and the width was 52 feet, and the height, let's leave it at 14 feet. So now, as you notice, it actually is telling us that we need a four-channel, a four-row system in order to completely monitor the space itself. Go to next. Now this is what I was referring to. For the fact that we had the DXF file, by choosing the direction of the pipe network, that's the way it's actually going to show up in relation to the DXF. So for the fact that we know the detector's on top, we want to go from top to bottom. We want to switch it to top to bottom. Go to next. Everything seems fine. It's going to be inside the room. And it's finished. So it actually created the system for you. Okay. We want to, you have the ability to toggle between on and off of the DXF itself. So if you don't want to see the DXF file, you have the ability to turn it off in order to zoom extends on your design itself. And if you want to see the DXF file again, all you would need to do is just bring up the DXF. Okay. PipeIQ might seem complicated at first, but once you get going, it becomes fairly easy. Just remember the first time you use Revit or any design software, I'm sure that was a fun learning curve. So make sure to download the latest version of PipeIQ and have fun with it. There's no easier way to learn than giving it a try. Thank you all for attending. This concludes PipeIQ Design. David, back over to you.
All right. Thank you, Nick. So we've got a couple things we want to cover here, and we've got a number of questions that are posed. We are asking questions or answering questions offline, too. So for those of you, we've had dozens of questions posted. Some of you are getting direct responses from either Luis Barros or Krista Poss, our two FAAST experts that are offline. So just want to remind you that systemsensor.com/FAAST is a great resource site for you. You'll see some videos, some product demonstration videos, link there, as well as application information, data sheets, FAQs, training and case study. And just a reminder, some of you have asked for that web address again for design support. For design support, visit that systemsensor.com/FAAST design. Which would be great. So we'll go to the next slide here, which is the contact information of our two presenters today. If you'd like to ask them a question directly, there is their email information. We'll leave that posted. And I also want to, at this opportunity, launch our last poll question. And really, our question here is, how can we help you? We've covered a lot of data today. Would you like information on the FAAST detector? So those first couple ones are related to the FAAST aspiration smoke detector, whether it's a data sheet or brochure. That's the first check. If you want engineering specs or the CAD file, that's the second check, and we'll send those out to you or send links for those out to you so you can download those. The third one is if you want to link to the PipeIQ free software download, go ahead and click that box. And then the final ones, perhaps you have an aspiration project in the works and you'd like some help from Nick and others on that custom design. We love to do those for you. So click that box if you'd like to be contacted about a custom design or actually to get the link to start that submittal process. And then finally, perhaps we piqued your interest here, you'd like to learn more about FAAST and you want to talk to one of our representatives live, click that last box to contact me. So we'll leave that up for a while. Hey guys, we do have some questions posted that we want to get to live here. First, they're asking if the design service is free of charge.
Yep, it's 100% free of charge.
Excellent, excellent. Second, I think we covered this early on. They saw that all of your work was in feet, and they want to make sure that it's able to be translated into metric as well. That's one of the first settings that they pick.
Yeah, so the first prompt when you create a new design file is whether you want to use a U.S. customary system or the metric system. So both are fully supported.
Okay, very good. So they're wondering what the day-night level is. I think that was maybe in relationship to acclimate, perhaps?
No, so the day and night level allows you to set the system to different obscuration levels for the day and the night. So, or just 2 periods of time, essentially. So you have the ability to set when you want nighttime to start and when you want it to end.
Okay.
So if you have if you're deploying FAAST in an application where, say, there's a process running and you know there's going to be elevated particulate level in the air, you have the option to decrease the sensitivity of the device during that time, and then have the sensitivity increase again when you know that process is going to be over. If you just want the device to be set to a static alarm level 24 hours a day, you would just set the obscurations for day, night, and weekend to the same level.
Okay, good, good. Next question I think I can answer. They're wondering about the CEU certificate for attending this webinar. We will send that out electronically, so watch your inbox for that. It should be out in the next couple hours. So that will be coming your way. So guys, next question here. Can you design for a system space that requires coverage above and below the ceiling?
Yes, you could actually design for any space. The only thing we do recommend is having separate detectors, only for the fact that you might run into pressure differentials. So, for example, if you have a data center, we wouldn't recommend monitoring the ceiling space and underneath the raised floor, for the fact that each zone has different air circulations and pressures. But if you require to monitor the space itself, we will recommend putting a detector for each.
Okay, very good. Someone commented on some feedback there that I think we had a couple mics open at the same time, so sorry about that. Can you modify, he's saying the orifice size, can you modify the size of the hole in the piping, and how does that impact the design?
You can modify the hole size. It will impact the design based on your pressure itself and your transport times. So as I mentioned, all you will have to do is double click on the pipe itself, and once you actually get to the location of the hole diameter, if you scroll down, it gives you a range from 5/30 seconds all the way to a 1/4 inch hole diameter. And by doing so, it will modify the system. It might not necessarily affect the flow itself, but it might affect the transport time. So it really depends on the system itself, the length, and how many sample ports you have.
Okay, all right, very good. Next question, do end caps automatically get holes, and should they?
Depending on the system itself, me personally, I don't, if you have a ceiling, above ceiling application, obviously you don't want to have a end cap with a hole if you're using capillaries, because you're monitoring a void opposed to monitoring below the ceiling itself. So when you do the design, it's actually going to give you a sample port on it. But what we would recommend is actually putting a no hole on the end cap unless you really need it. But you have the option between toggling to put a sample port or no sample port.
Okay, all right. We do have a bunch of questions in here, so we'll get to as many as we can in the hour reserved for the webinar. If we don't get to your question live, go ahead and contact one of our presenters, and we'll also look through the questions here. I'm going to leave the poll question up for just another minute, and then I'll take it back down so you can see their contact data. Guys are wondering about the total length permitted for one system. I believe they're talking about the total length of pipe.
Right. The total aggregate amount of pipe is 328 feet. That's for a branch system, and the total amount for a single pipe run, so one straight pipe, is 262 feet.
Okay. All right. They're wondering about the software. Does it run on Windows 7, Windows 8, something else?
Yeah, it's supported on Windows XP, Windows 7, and Windows 8. Those are the 3 operating systems that we currently support.
All right, very good. Is reduced spacing required for underfloor applications? And they're saying like 2 and 3 feet height, for example.
Well, the spacing for underfloor applications would really be decided by NFPA 76, so which is going to be very early warning for data centers. So your spacing will be 200 square feet. If the space itself is under 2,500 square feet, NFPA 76 allows you to be to move the classification up to early warning fire detection. So your spacing at that point will be 400 square feet per sample port. So it really depends on the classification and the square footage of the area itself.
Okay, very good. They're asking about within PipeIQ if they can have customized angles, for instance, 135 degrees. Is that possible?
No, we can't put 135 degrees on angles, but what I've actually done in the past is, in order to create such angles, so for example, for dome applications, What you would do is create sort of a pipe swing itself and then angle the pipe accordingly.
Okay, all right. Let's see here. We'll get to some of the other open ones that we haven't answered already. Let's see here. So we have answered a bunch offline, so if you don't hear your question to ask, they're talking about pipes here. What type of piping is recommended for PipeIQ or for FAAST?
So the standard pipe that we use is a CPVC pipe with a BlazeMaster resin. But any pipe material, as long as it meets the internal and external diameter requirements, is acceptable as long as it's approved by your AHJ. So if you want to use copper, PVC, PE, that's okay. Again, FAAST only really considers the internal and external diameter of the pipe.
Okay. All right. They're asking another certification question here. They're asking for the length of time of the certification. There's not a length of time. We offer the 0.1 CEU credits to allow engineers that are taking this as training to be able to qualify that within the year of their qualification. So can't be used in subsequent years.
Yeah, and David, just in case they might have been asking about the actual FAAST certification course, that's
sure.
Generally about a half-a-day course.
Oh, okay, sure. Sure, that could be it as well. Okay, we are at the top of the hour, and we do thank you for participating in our webinar today. Steve and Nick, nice job. Thank you for that, and also for the audience. We have a large audience with us today. So on behalf of System Sensor, I do want to thank you for joining us. As a follow-up, we will send you a brief survey in about an hour, and would appreciate your help in filling that out. And we do plan to reward one of you that completes the survey with a $50 Amazon gift card. So thank you for joining us. This does conclude our webinar. Please have a nice rest of the day.